let me just share my slides. The screen is visible, right?
Sir, it is visible.
Okay, let me start with the title. Start with the name of Allah Almighty, ever compassionate and merciful. It's really an honor to be the part of this very fine event that is named as Plugin 2020. And I'm really acknowledged that you people have invited me, even though we have been facing the pandemic situation since January 2020, and still we are reviving ourselves. But the way you people have managed this event is really appreciable. So the topic of my today's presentation is review of hybrid control designs for underactuated quad rotor. So this is somehow a technical topic related to the control designs and related to the unmanned aerial vehicles, the autonomous vehicles. So starting from my introduction, it's me, Ghulam Mustafa. I have been pursuing my PhD studies in Department of Electrical and Electronic Engineering, University Technology, Petronas, Malaysia. And the research interest that I have been pursuing is intelligent control system design, the study of underactuated system, on which I will be just conducting my presentation just now in few minutes. After that, I have somehow research interest in autonomous vehicles and Internet of Things. Actually, it's not Internet of Things; it's Internet of robotic things. So my somehow the research interested in robotics and the mechatronic systems like that. After that, I have been and I am still currently volunteering for IEEE, and currently I'm volunteering as a chair professional activities student activities committee of Malaysia section. And apart from that, I'm also tackling some of the responsibilities as a volunteer at here at UTP. Many of you can contact me on this email address, that is mustafa.abdo@iEEE.org. So starting from the slides, this is the fashion that we are going to follow today about our presentation, that is introduction. After that, I'll be describing somehow the literature review. This will just create an interest to the people who are from bachelor's and masters even, and if they are going to pursue their studies in PhD or in masters by research, and specifically in the area of control systems, then this literature review will be helping them a lot. After that, I'll be discussing the challenges and constraints, and our last but not the least is conclusion. So starting from the introduction, if you see unmanned vehicles over here, these vehicles have got popularity since a decade, and they have been using and they have been used in various aspects. They have been using in dull environment. They are used in dirty environments, difficult and dangerous even. You can see these unmanned vehicles by military. You can see these unmanned vehicles by the marketing or for publicity purpose, for the promotion purpose even, or even the most common thing that we are having nowadays, the use of unmanned vehicles, is the photography, the aerial photography. After that, these vehicles are of several types. So you have a vehicle that is running on a ground, is known as unmanned ground vehicle, which is UGV in short form. After that, a vehicle that is running or operating in a sky, that is UAV. So this presentation is focused on UAV particularly. And if there is a vehicle that is swimming in or beneath the water, that is known as unmanned underwater vehicle. So if you can see over here, these are the equations that basically help us, a mathematician or an engineer, to drive the equation, or you can say that can turn turn a physical model into mathematical model. So if I just jump over this mathematics and just create an interest in you, then these equation number 4 and equation number 5, these are the equations that define the system, whether it's underactuated or it's fully actuated. So let me just clearly to you the concept of underactuated systems. If you have a system, let's suppose it has 4 motors in it. and through that four motors, you are driving your vehicle to front, left, right, and backward, right? So you have 4 degrees of freedoms. It means your vehicle can go forward, backward, left, and right. So four motors and four directions. It means it's fully actuated system. But if your motors are four, but the degree of freedom is greater, you can move in between left and right, something like 45 degree in between left and right. It means now the degree of freedom are increased. So whenever you say the degree of freedom is increased as compared to the number of control inputs or the motors or the actuators, we say it's a under actuated system. So why we call a quadrotor as an under-actuated system? Because quadrotor is a vehicle that has four motors, four propellers. It fly in the sky and it can travel into 6 degrees of freedom. So four motors, but 6 degrees of freedom. So motors are four, but the degree of freedom is greater. So it means it's under-actuated system. Apart from this, we have two-wheel mobile robot, a robot that is running on a two-wheel, back, front, left, right. So 4 degrees of freedom, but the number of motors are two wheels. Again, it's an under-actuated system. The tri-rotor unmanned aerial vehicle. Again, tri-rotor means three fans, three propellers. So these are the under-actuated systems. Why we study under-actuated systems? Because under-actuated systems have less number of actuators or less number of motors. They consume less power. And apart from that, it has been said in control engineering that if you propose a nice control algorithm for that, you can stabilize the unmanned vehicle very finely. It means that you pay a low cost on the hardware and the low power consumption. So it's quite better as compared to obtain a hexacopter. It means that it will have, six or more than eight, motors and 8 degrees of freedom. It will consume much more of your power, right? And much more the hardware cost also. So this is one of the objective of this particular presentation, that we should go for the under-actuated systems. As you can see over here, I have written two thrust satellite. The two thrust satellite, first it was imposed, it was fully actuated, but then people realizes that it consumes lots of power, so they modified it, and by modification it turned into under-actuated system. So now it consumes less power. So these are the advantages of under-actuated systems. So now if we discuss particularly the model of quadrotor, if I just jump over this slide and just go through the picture, it would be quite easy to understand. These are the four propellers, 1, 2, 3, and 4. So it should be noted that each adjacent propeller will cover the RPM in anti-direction, right? So if this F1 is revolving in clockwise, then it should be, it must be F2 must be revolving in anti-clockwise. This is because to cut the forces balance and try to lift the quadrotor upward. So we obtain the equations through Newton-Euler dynamics. This is one of the people who have read or who have studied the numerical methods in their engineering. They know about Newton-Euler dynamics, that how we drive the differential equations, how we turn them into state space, and how we go through the modeling techniques, right? So in this particular literature, what I did was simply I have gone through the modeling approaches, then I have gone through control design. So when I just peeped into the literature of control design, there are several control designs for multiple flight modes, for the ground effect, for the rotor efficiency. So for the rotor efficiency, if your drone is in the sky and somehow any of the propeller loses its efficiency, then at that moment, your control algorithm should be much enough capable to drive your drone towards its destination. So this is one of the objective of this literature. When I just go through the different things, and last but not the least is techniques for unmodeled dynamic factors. These are the factors that people, I have read the literature so far, and to the best knowledge, as far as my best knowledge is concerned, I have read through several contributions, and over there, people have used the approximation methods or estimation methods for tackling these unmodeled dynamic factors. No doubt, this is the only way. But in the last, I would like to highlight that what was the actual problem. So, if we see the literature for modeling techniques, there are several modeling techniques. People use Newton-Euler dynamic model. People use sensorization or using the sensors, that is known as system identification tool. They acquire the each and every data of the drone, that at what height it is, at what angle it's revolving, what is the parameters during when it hovers at one place, when it tracks the path particularly, or when it do aggressive maneuvers. So all that particular data is adopted using system identification and put inside the MATLAB or Simulink, and they do the simulations. And similarly, later on, when they are about to validate the same results, they use to burn all the data into a microcontroller, and then so microcontroller are also advanced nowadays. People mostly use Mario controller for this purpose. So if we just come over this particular thing, then there is still something that is remaining. People are doing very fine job in the system identification technique. The only problem for this is whenever you fly your drone, before that you have to acquire the parameters. So it's quite impossible that for individual flight, you again and again note down all the parameters and then tune up your gains of controller and then go for a flight. So this is quite difficult for individual flight. After that, when I just realized that there is another problem, that is ground effect. So if you can see in figure 1, whenever the drone is in the mid of air, there is no any kind of problem. But when it is near to the ground, the thrust that is basically creating over here, it basically make a turbulence or make the vibrations in your propellers as well as your drone. So that is known as ground effect. Now, people have looked into these particular cases like multiple flight modes, like hovering, like tracking path from one place to another. And they have proposed, if you can see this particular block diagram too, we have 3 different controllers, and they are switching with a switching mechanism, right? So with the switching mechanism, they can perform very fine job, but again, there and it can damage your propellers, and in the mid of somewhere your drone may not complete the mission or may not complete the track. Okay, after that, these are the flight mode techniques that all I have gone through. I can give you this presentation just after the session. You can read about every control design and their pros and the cons. After that, we have some drones, the control designs. They have used modular physical redundancy. So what do you mean by modular technique? Modular technique means they have changed the design of drones so that in the case of any uncertainty or any fault tolerant, the drone must have the capability to resist for that fault. But anyhow, when I just come across with all the literature and going to conclude all the things together regarding the uncertainties, regarding the multiple flight modes, I come a conclusion that what is the challenge, right? So one of the biggest challenge with respect to model is that our model that is on Newton dynamic model, Newton-Euler dynamic model. Actually, the problem with that is if we just compute the state space and we find the whether the matrix is singular or not, so we come across with the singularity issue. So what is the singularity issue? Due to this singularity issue, if your drone is traveling into a sky, suddenly if it just do the maneuvers, aggressive maneuvers, somehow due to singularity issue, it will lose some of the degree of freedom. It will lose somewhere. If you want your drone to do some particular maneuver, like it's going like this way and it just roll, or it's just do the pitch, so somehow at that moment, due to Newton-Euler dynamic motion and the singularity issue, it cannot be able to do the roll. It means that now you are losing some degree of freedom. So this is what actually your Newton-Euler dynamic model has a constraint. So what is next thing to achieve that thing? That is, we should go with the vector analysis thing. We should go for the quaternions, that is vector oriented models. So in vector oriented models, we cannot face such issues. Second issue with Newton-Euler dynamic motion is that whenever you are adopting the dynamics of a drone or quadrotor specifically, you have sine cosine functions. So sine cosine functions, whenever your algorithm is computing sine cosine functions, it consumes a lot of times. It means that process time is also increased, number one. Number two, after having a lot of process time, the second thing that is very concerning thing is whenever you have high process time, you will use the bigger controllers. You use bigger controllers, not in terms of that huge size. Big controllers means price for the controller. If your process time is increasing, obviously the drone means you need aggressive maneuvers. It's just not like that. If your drone is moving maneuvers like with the blink of eye, just go for this. Whenever your drone is in the sky, right? If you have a robotic arm, that is, or robotic ground vehicle in a room, let's suppose you have lots of labs, lots of class, and over there, if you have a small vehicle like unmanned ground vehicle and that is running in between a class or in between a layer, it means that now you have bounded system, right? You have the bounded system, so you can adjust your ground vehicle within that room. You are not going out of that room. But for the drone, the sky is the limit. It means that you are boundless now. So within the sky, there are several factors. You have motor coefficients, you have air disturbance, you have gravity, you have several noises, several model dynamic factors. So every model that have been proposed previously that were based on observers. So when I went through the observer techniques, I read the literature, I found that there is no any kind of predictive algorithm for the observing and estimating these unmodeled dynamic factors. This will lead us in estimating the results with a time delay. And with the time delay, our drone again will not able to do the aggressive maneuvers. Someone can ask me in the audience that, sir, you are doing a good job in the drones, but nowadays the drones are of various types, and US and Germany and all the people around the globe are working on drones, and they are much advanced now. Yes, they are advanced, but just give a look on small drones. If you purchase a small drone, just fly it within the indoor environment. Just turn on your fan and drive that drone beneath your fan. Try to increase the speed of fan and then try to hover at one place. Your drone cannot hover at one place at the moment when you have a wind disturbance at upward, just like a upward, like a shelter beneath the drone. So your drone will start doing what we say, it's a chattering phenomena. It will just vibrate at one place. cannot stabilize. You will have the tracking errors at that moment. So this is the problem with the small scale drones. And for the large scale drones, we have another issues. So still people are optimizing those issues. So this is one of the objective of my doctoral studies, that I have to be concerning about these unmodeled dynamic factors, number one. Number two, and the number one was to drive a dynamic model, not based on the quaternions, not based on the Euler, but to use somehow a quaternion or vector analysis to drive something that have the built-in capability to tackle such unmodeled dynamic factors. And after that, the optimization techniques in the presence of fault. So whenever my rotor is losing somehow efficiency, let's say 15% or 10%, not 15% actually, but 10%, or some people have worked on 15% also, but I'm amazed that for 15%, the people are working how they are working. So I'm still studying that literature, but for my case, I have I'll be compensating the 10% rotor efficiency for my drone. If my drone is traveling from one point to second point, between the travel, if the efficiency of any one of the rotors, the propellers, is lost by 15%, then still my control algorithm should have the capability. My controller should be robust enough that it can travel my drone from one place to another in the presence of rotor efficiency loss. So these are the constraints that I'm going to do, and it was my first review paper that have been accepted in one of the Science Citation Index journal, that is Measurement and Control by Sage Publishers, and soon it will be also available for the study. So it's already accepted, and yesterday some part of that also I presented in one of the international conferences at UK virtually. I wish that I could have been visited UK for the second time, but unfortunately this pandemic situation has restricted me to come back to Pakistan to see my loved ones and to meet Dr. Abdul Sattar also. So these are the things that have been going on nowadays in my doctoral studies, and it would be a wonderful part that I shared all of these things with you people. So over here, I just want to acknowledge a few of the people that I want to acknowledge my Center for Graduate Studies, University Technology Patnas. I'm just memorizing and remembering and learning the things that I have been taught to me by Dr. Abdul Sattar Samsa, because he is also an alumnus of this university. So I used to get the advices from him, and he is very humble person I have ever met. And after that, I just want to acknowledge the Global Data London. It's one of the corporate firms that used to spend money in the research. So they paid the publication fee for my research journal paper. And after that, special thanks and a special courtesy to my supervisor, Associate Professor Dr. Vijay Sagyana Srivaddam. He is from electrical department. And after that, we have Dr. Sheffel. He is my co-supervisor, and both people have worked a lot on me and taught me the real skills that to be furnished and to be refurb, for the production of a quality research. So over here, the environment is very fine, and I hope that with the advices of Dr. Abdul Sattar and all my mentors out there, specifically Dr. Abdul Sattar, Dr. Waliuddin from Sir Syed University, and Dr. Zain from Sir Syed University, and Dr. Syed Sajjad Ahmad Rizvi. These people, I must say over here to the students that whatever you are or whatever you will be in the future, you will be just because of your university, just because of your alma mater, and just because of your teachers that spend a lot of time on you. So a piece of advice from my side is that always, always, always respect your teachers, because these are the people who make you to earn someday, somehow, for your family, for your maybe mother, for your father, for your wife, for your children. So these things are very, important for you to take care of your alma mater. Even today, I have been graduated from Ahmedabad University. Even today, whenever I just see any picture of Ahmedabad University, I used to remind my olden days and my olden times that okay, it has been a very long time that I haven't gone through those places, and it reminds me many of the memories of my batch fellows. So my batch fellows today are in various countries and pursuing the higher degrees. So that was all from this presentation, but yet I have to say that I have to somehow spend some time for foreign scholarships. So the handy scholarship that you people have now, the people of Qaid Awam University, one fact, my father and my uncle have been graduated from this university long time ago. So my father did mechanical engineering, but at that moment, Mehran University awards the degree. And then my uncle did engineering in civil department, and then it turned to be a full-fledged university. So there is a very emotional contact or emotional, relation with the Qaid-e-Awam University that I have. So the people of Qaid-e-Awam, even the students that can grab up the opportunity for scholarship that is in Malaysia, immediate and very fast and very, what we say, prompt scholarship that you can have is in UTP, University Technology Patronage. Why I say this thing? Because you have a very fine mentor with you, that is Dr. Professor Dr. Abdul Sattar. So he can guide you very well. Apart from that, I am a person, I am here. So I have been learning from the experiences from Dr. Abdul Sattar. So you can just forward your CV to Dr. Abdul Sattar, and he can forward to me, and then I will go through the several faculty members over there and may connect you to the person. So it's quite handy for UTP, because people are here from even Qaid-e-Awam. Moreover, apart from that, I have very strong what we say, the social circle in within the Malaysia also, within Italy and UK, because a long time ago in 2018 I have been there in UK for 2 to 3 months, and over there I presented one of my research papers, and I visited UK a lot. So believe me, the culture, the diversity of a foreign country is something that you must go through. So for that, those countries like UK or Germany or Japan or something like that, I can also connect you some of the people that are very humble, and they will feel proud to contact you. But the most important thing for you people is when you come up in third year or in final year, you must clear your IELTS, because without IELTS you cannot achieve a good scholarship. IELTS is, there are certain universities that does not demand IELTS, right? But the problem is that when you don't have IELTS, it means that you can get admission at any university, but that university will not have such ranking. Obviously, it would be far better than the educational status than the Asian countries like Pakistan, India, or something like that. But still, I feel that if you are getting something, then you should spend something on IELTS. Because after getting IELTS in 6.5, I just define getting IELTS is just like you were competing with 50 people, right? So when you get IELTS, you will be competing with somehow 10 people or 8 people, because many people just like people have an opinion that without IELTS we can get admission in any university. So people having this opinion are many. So in many people, the competition is somehow tough. But if people who have IELTS, they are somehow very few. So competing with them is quite easy. So this is just like that. For US, I don't know about much about US. For US, you have to clear GRE, and then you have to do the TOEFL. But for UK, You can go for the Shivering scholarship. The things that I know, I can do or guide about those things to you specifically. I have also mentioned my email address, and I can also guide you as well when you just contact me through email or the WhatsApp. The Salim Ahmad from Quest, he is one of the brilliant students and very active, and he has my number, so you can grab my number from him and can contact me regarding the scholarships. Okay, I suggest that utilize your time, because COVID-19 is not a crisis, is not something that is you count it into crisis. There is a Chinese word crisis. If you see the word crisis in Chinese language, it decompose into two things. Number one, crisis. Number second, opportunity. So if there are crises, there would be so many opportunities. Be somehow positive in terms of your mental approach. Do positive things. Try to run away from all the negative energies. So this is how you cope up the things, and this have been taught to me by the mentors like Dr. Abdul Sattar. Which else or subject? There are two types of IELTS. Number one, there is academic, there is general. So for academic, if you are going for academic, it means you are going for higher studies. For general, it's for the immigration purpose or the job purpose. So don't go for the general. Go for just the academic purpose. And for the academic purpose, the minimum score that you want to have is 6. My score was 8 or 8.5, I think. But I prepared with the online material. I have the online material. We can conclude any other session, provide you the tips for the IELTS. My highest score was in speaking. I got my 9 band in speaking. So if you people need that counseling, I can also give you that counseling, but try to be positive. There is no any shortcut. Without struggling, without hard working, you cannot achieve the moon like milestones, right? You have to struggle hard and you have to work hard, and parallel to that you have to respect your teachers and your mentors, because without that, and most importantly your parents, because these are people, through their positive energy, through their prayers, you can achieve a lot. So apart from that, I can guide you a lot, as far as my experience. But my experience is not that much as the mentors that you have already over there in Kaidewam, and they people are very amazing. And still today I feel very honored that you people associate me in your events and your competitions. So really humble in that. These are the references for the entire my presentation. And if anyone is willing to work in this domain, and anyone who can just pick up the final year project for that, and I can guide you that what type of deficiency that you can address through your final year project, and this will help me a lot also in my doctoral studies. Okay, so if you have any sort of question answer, by the way, this is one of the buildings that we have in UTP, that is Chancellor Hall. I hope Dr. Abdul Sattar is reminding or is remembering the memories that he used to grab the bus from here. So this is
Yes,
all
it's a
from
very
my side.
yes, it's a very beautiful place.
Yes, sir. Obviously, sir, it's a very beautiful place, and it's calling you again and again. And I hope that one day you will come over here again for some sort of research collaboration, inshallah.
Inshallah.
So this is all from my side. And if you have any question regarding my presentation, regarding anything that you want to ask, this is a very fine platform. You can ask. Anyone?
Sir, I have given posted a question on the chat. Please kindly see.
Okay, sir. Okay, let me just see. Okay, from here, okay, over here we have to stop share and the chat. Okay, a big drone based on already matured aerodynamic platform, why you choose heli models since heli fans have their own complications. Okay, so my topic was not limited to the size of drones, whether the drones are big one or the small one. My neither my topic was related to the aerodynamics of the certain platforms. My topic was based on the control design, in which researchers always use the approximation and estimation approach to find out the parameters that are changing instantly. So they face time delay, they face some tracking errors in that. And the objective of my doctoral studies is to address that issue with any predictive algorithm, any predictive or hybridized algorithm that should be amalgamated with the observers or the estimator control design, so that the performance should be improved. Let's say, I'll give you an example. If there's a drone, whether small or big, and if you attach any weight, like if you have this Pringle box and you attach that with the drone, so when it just going to release it, and you have proposed, there is a paper, in that paper they have proposed a integrator in that. So integrator reduces the overshoot, right? Integrator, sorry, derivative reduces the overshoot. But when you just drop it, what will happen with this? It is not experiencing any overshoot, right? But when it drops it, in the absence of this thing, the derivative will not work. So again, it will experience somehow a bigger overshoot. So with derivative, with this weight, without this, with derivative, these are the certain combinations, right? So with these combinations, you cannot stay in a multiple flight modes. Similarly, if this particular tank is somehow containing a water, containing a fluid, like we have proposed one of the grants in that, we have proposed that a drone will just spray the disinfectants. So if the mass of this particular tank is reducing somehow gradually, that is known as smooth disturbances. So we must go for the observer design that can address both things, the smooth disturbance and the non-disturbance. The second question that we have, what are the main types of sensors you prefer to use? Okay, for the main type of sensors that we are going to basically for the unmodeled dynamic factors, there are, my work is not on the sensors again, but to acquire the data, what I'm going to do is I'm using the system identification technique. And in system identification technique, we have a certain lab, in that we have motion sensors, we have the fans that will create the wind disturbance, and again we have certain accelerometers, we have sorry, lidar, lidar. It's one of the sensors that can compute the distances and all the things, but it's working on, it's just like ultrasonic sensor, but it works not on the ultrasonic waves, but work on the what we say, the light wavelength. So there are lidars, there are certain, so combinedly we have a certain unit that is known as inertial measurement unit, that will drive us all the things, and we can have wirelessly, and that GPS module, that is also one of the part of that inertial measurement unit. I hope I answered the questions. Am I clear to you, Sir Abdul Kadir?
Thank you very much. So you have done a lot of augmentation in my knowledge. I hope we will be learning more from you. We'll be listening more from you and increase our knowledge. So thank you.
Thank you, sir. Thank you once again. Any more questions from the audience? Any question regarding the studies? Any questions?
Sir.
Okay, just go on the YouTube. You will find there are many technical and non-technical topics that I have addressed. You can go in that and you can just subscribe me, so that I can give you some of the upcoming lectures on control design. Whatever the simulation I'll be doing, I'll be posting on the YouTube so that I may quote it into my publications also, and I can advance the knowledge of my upcoming peoples. Okay, so for that, even not only the control design, but somehow I do the motivational talks also, and addresses the advantages of joining IEEE also. So these are the three domains that I'm going to address at every spot. So if you want those previous videos to listen, then you can go for this thing, youtube.com, Engineer Ghulam Mustafa Abro. You can go and check over there. I have certain simulations regarding COVID. So I modeled this particular disease model of COVID-19 into the mathematics, that is susceptible, exposed, infected, and recovered model. I changed it into, I applied the MRAC, model referensive adaptive control, in that, and I just produced the simulation. So you can go and check that video also, and you will able to see that how being a mathematician, being an engineer, or being a student of science, technology, engineering, mathematics, how we can contribute to the society, right? And this is the very positive thing that always observed by the person who is going to offer you the scholarship at any foreign country. So I think that whatever the FIP you choose, you must have some community services in that. That is very big thing and very notable thing in in the foreign countries. So with this, I conclude my session. I hope that you enjoyed the session. If there is any query, you can write me on mustafa.abdo@ieee.org. I'm just like you. I belong to Lalkana city, a very rural area over there, and that is known as Rawat Khan Abdo Talko Bakrani. It's one of the villages over there. So I belong to that particular area, and with the struggle that I did, and with the teachers and the mentors like Dr. Abdul Sattar and Sir Waliuddin and all the people around, they helped me a lot in grooming myself. We have 18 engineers in our family, but I'm the one who just reached at the destination of PhD. And inshallah, with the prayers of all the loving ones, I'll make it someday. And thank you so much for the love, for the respect that you blessed me by inviting here. It's been my fourth time that I'm addressing the love, the brilliant audience of Qaid-e-Awam University, Nawabshah. Thank you so much.
Thank you, GM. Thank you. Thank you for your nice presentation. A lot of knowledge you have shared with the student. Thank you so much again.
Thank you, sir.
He was Engineer Ghulam Mustafa Abro, doctoral student and our today's technical speaker from UTP. He is an eminent scholar and an academician and a certified professional electronic engineer. He is also a gold medalist for securing first position at undergrad as well as graduate levels by Hamdard and Sir Syed University. We are very honored. Thank you so much, sir, for being with us today.